What's up? It's Math and Beats. How y'all doing? I hope good. Welcome back. Today we're going to do a video on what unions and intersections of sets are. Got my coffee with me. Hold on one second. It's delicious. All right. Here we go. First, let's just remind ourselves of what a set is. Well, recall, a set is any collection of objects, anything. There's many different ways to write sets. We can use the listings notation, set builder notation, and interval notation for real numbers. Those are the most commonly used ones. So we want to talk about what if we have multiple sets and we combine them in certain ways. And to do this, we're going to start off with a couple of Venn diagrams here. This helps us to visualize a couple sets. All right, so we better label each of these. The blue circle we're going to represent with set A. It's called set A, and the red circle's set B. So what are in these two sets? The circles just represent the idea of what's in the set. So everything is in A, is in that blue circle. Everything's in B is in the red circle. We'll just make something up. How about A is 1, 2, 3, and 4? That set right there. And B is, how about 1, 3, 5, and 7? Notice that the numbers 1 and 3 are in both of the sets. So you see with the sets overlap, I'm going to go ahead and do that. I see that 1 and 3 are in both sets. Whoops, not 5. 3. They're in both sets. So I'll draw 1 and a 3 in that little part because they're in both at the same time. That's where the circles overlap. And then A also has 2 and 4. And B also has 5 and 7. So there's a little picture to help us visualize what's going on here. All right. So in the first part, we would like to ask, what numbers are in A, B, or both of them? Well, everything that's in A, or B, or both. That would just be everything that we see here. So all that stuff together. So we could write this as the set 1, 2, 3, 4, 5, and 7. It's what's in A, it's what's in B, or both. So it doesn't matter if I ask, is 5 in this set? Yeah, it is, because that's in B. Is 4 in this set? Yeah, because it's in A. Is 1 in this set? Yes, because it's in A, and it's also in B. This is what we call, in this example, the union of A and B. Go figure. We're in the second diagram, the Venn diagram. We want to ask the question, what numbers are in both A and B? Well, we can already see what's in both. 1 and 3 are in both A and B at the same time. 2, 4, 5, and 7 are not. They're in A, but not in B, or B and not in A. So what is this set? This is just the set 1, 3. And that is what we call the intersection of A and B, helping us introduce the concept. So, what is the definition of the union and the intersection of two sets? We'll see it right here below. And that is the union of two sets, any collection of stuff, A and B, denoted by A union B, right here. So that symbol, that U looking thing, that is the union symbol. And this set, A union B, is the set of elements which are in A or B or both. So it's just all of them thrown into the same bag. That's what a union is. And then when we talk about the intersection of two sets A and B, denoted by A intersect B, so that symbol right there is like an upside down capital U looking thing. That is the intersection symbol. All right. And what is in that set? It's the set of objects which are both in A and B simultaneously. They got to be in both, not one or the other. That's kind of the opposite idea, like as a union. So now that we've got kind of a silly example out of the way and the definition, we got a couple of examples to look at down here that have to do with some mathematics or just we see some numbers. So we got two sets here in the example. What we see, sets A and B, A being 1, 2, 3, 4, and 5, and B being the set 2, 4, 6, 8. We want to find the union and the intersection of each of these. So the union, which is A union B, that's going to be the union of 1, 2, 3, 4, 5, because that's set A. Union that with the set B, 2, 4, 6, and 8. If you want, you can have the little Venn diagram while you think of such ideas. Here's A, here's B. What's in A? 1, 2, 3, 4, and 5. What's in B? 2, 4, 6, and 8. So say, all right, if we're going to find a union, take everything that's in A, or what's in B, or what's in both. We can see that there are two elements that are in both. That is, 2 is in both, and 4 is in both. So even though we didn't write them in the middle, we certainly could have. We could write it if we wished, now that we identified those with the 4 and the 2 being right there in the middle. And so what's in A or B or both, it's all that stuff without repeating elements, and that is 1, 2, 3, 4, 5, 6, 8. Ha, got you. You thought I was going to say 7. And there you go. There's the union. Whereas the intersection, we can see it already in our picture, but we might as well write it. That's A intersect B. So that's 1, 2, 3, 4, 5, set A. Intersect with set B, 2, 4, 6, 8. We just pick out what is common in both of them. And that is, as we see in the diagram above, the numbers 2 and 4. So this is the set 2, 4. So we found them. An example with some numbers. One more example, and then that'll be it for the intro. Down here, we have another example, and this time we are given sets C and D in interval notation. So these are collections of real numbers, if you recall. Everything in between the two endpoints. In C, we do not use the endpoints -1 and 5, and in D, we're not including. We actually are including the endpoints -2 and 3. So we want to find the union and intersection of these two sets, similar to how we did above, except in these, we actually have an infinite number of elements. And by the way, recall that the word elements is just another way of saying the things in the set. So, all right, we could draw a number line for each of these to help us visualize where sets are coming from. So here is going to represent set C. So that, if you recall, we draw an interval like so. Here's -1. Here's 5. It's the real number line, 0 in between somewhere. And it's everything in between those because it's an open interval. Whereas set D down here, I'm just going to stack a number line right on top. -2 is maybe somewhere down there. And then 3 is maybe somewhere about right there. Here we're going to draw dots at the endpoints and also shade everything in between. So those are two graphical representations of these intervals. So if we want to find the union, excuse me, of C and D, C union D, then we're going to union everything that's in this first set and the second set. So we can see what that is above. Remember, that is everything that's in one or the other or both. So it's got to go all the way from -2 up to 5. Everything in one or the other or both, everywhere they overlap. So we're going to start from the far left, -2, that's included because of the point. And then we'll move all the way to the right to 5, but we do not include the 5 because it's not in either of the sets. You may be wondering, what's up with that -1? It's not in set C. No, it's not. But it is in set D, and hence it's in one or the other. Now, for the intersection, C intersect D, intersect the sets -1 to 5, and -2 to 3. Now we got to ask ourselves, what are all the numbers that is common to both of these sets? So that's where they overlap. So you can draw a line, this blue line here, and as we see, everything that is between both those blue lines is common to both of the sets, not including the -1. So where do we start? -1, and then we include everything up to and including 3, because that is in both sets. -1 is not in both sets, hence it is not part of the intersection. And there you go. There's introductory examples and definitions and concept of the unions and the intersections of sets. So that's it for this video. And you know what that means. It means there's time for beats. Subscribe and like. Later.